Okay, this is a problem from section 6.3. The graph of the equation x to the power 2/3 plus y to the power 2/3 equals 7 to the power 2/3 is one of a family of curves called astroids because of their star-like appearance, as you can see in the picture here, a given figure. Now we need to find the length of this curve. Now to find the length, what we have given is the length of, now we can find the length of first half quadrant portion. So this equation represents first half of this first half, the length of half of this curve on the first quadrant. So if we find the length of half of this quadrant in the first quadrant, then there are, let's say, the length from here to here, then if you find this is this curve is represented by this, okay, this equation. Let me just change the color here. So now we can find the length of whole curve by finding the length of this first portion, this portion, and multiplying it by 8, because there are 8 of them. That's what we have given. So we need to find the length of this half of the curve on first quadrant and multiply it by 8. So to answer this question, first of all, we should know the formula for finding the length. So this is the formula. We should know the formula for finding the length. So this is the formula we have given in this section. The length of a curve can be found by finding the integration of square root of 1 plus dy over dx whole square, where the range of x is from a to b. In our case, the range of x is from this point to this point. So this length, this L, gives us the length of half of the curve, in the first quadrant, this length, half. And then we are going to multiply that by 8 for finding the length of everything. So let's look at here. First of all, y equal this value is given. Since we are using this formula, so we're going to calculate this expression here first and simplify them. So the derivative of this expression is, by using the power rule, this 3 over 2 comes here down, 7 to the power 2/3. I'm just copying this. I'm subtracting 1 from 3 over 2, which gives me half, times the derivative of function inside the parentheses by using the chain rule. Okay, so the derivative of function inside the parentheses is the derivative of this thing, which is 0, minus derivative of this by using the power rule, which is 2/3 times x to the power 2/3 minus 1. If you subtract the 1 from this power, that will give you negative 1/3. Now just the simplification. This 2/3 and this 3 over 2, they will be cancelled out, but still you have a negative sign. And this expression here, x to the power negative 1/3, can be written as 1 over x to the power 1/3. So now we need the square of this expression to use that in this formula. So we're just squaring that value. And as you can see that the square of negative sign is positive, square of square root is just 1, and then square of x to the power 1/3 is x to the power 2/3. Now I can distribute this 1 over x to the power 2/3 here. That gives me 7 over x to the power 2/3 minus 1. Now we need 1 plus this expression. So if we add 1 both sides, that gives us 1 plus dy over dx whole square equals 7 over x to the power 2/3. We need the square root of this expression, which is square root of this, which is, there is a square, so it will give you 1/3 by taking the square root. Now we need to find the integration of this expression, which is not difficult, just a simple expression for finding the integration. This 7 to the power 1/3 is just a constant, so we can keep that constant outside. and we can find the integration of x to the power 1/3 by using the power rule for the integration, which would be x to the power 2/3, because 1/3 is on the denominator. So this is basically x to the power negative 1/3, and when you try to find the integration of that, that is x to the power negative 1/3 plus 1. If you simplify this, that will give you the 2/3. Okay, that's how we got 2/3 here and then 2/3 on the denominator. Now by using the fundamental theorem, we can plug x equals 7 first time and x equals 7 times the square root of 2/4. Next, we can bring this 2/3 outside. If you bring this 2/3, which is on the denominator, outside, it will be 3/2. And now the only thing we have to do is simplification. If I distribute this thing to first term and then second term, it will give me 3/2 from here. 7 to the power 1/3 and 7 to the power 2/3 gives me 7, minus 7 to the power 2/3 and 7 to the power 1/3 still gives me 7. 3/2 comes from here. Now we just need to simplify this here. 4 to the power 2/3 can be written as 2 to the power 4/3, and there is a 2 to the power 1/3. And if we do the further simplification, we can bring this 2 to the power 1/3 down, and then we can just subtract from 4/3. That will give us 1. So that's why we have half. And now in the first term we have 21/2. Second term we have 21/4. So to make the same denominator, we can multiply the top one and bottom one by 2, and eventually it gives us 21/4. But remember, this integration is only gives you the length of the half of the first curve on the first quadrant. We need to multiply this length by 8 for finding the length of whole curve. So that is our answer.